Okay, in this video we'll do two examples of dilations. We're going to dilate triangle ABC given a scale factor of 2. The variable that we use for a scale factor is k, and so in this example k is equal to 2. So this scale factor is what we're going to multiply the pre-image by to get our image. So here are the coordinates for triangle ABC. So we use this scale factor 2 to multiply each of these coordinates by that scale factor to get the coordinates for the image. So if A is at 1, 1, we'll multiply 1 times 2 to get 2 and 1 times 2 to get 2. So A prime must be at 2, 2. Right 2 and up 2. There is A prime. If B is at 2, negative 1, I multiply each of those coordinates by the scale factor of 2 to get B prime. 2 times 2 is 4, negative 1 times 2 is negative 2. So B prime is at 4, negative 2. From the origin I go right 4, 1, 2, 3, 4, down 2, there is B prime. Finally, C is at negative 2, 0, so I'll multiply each of those by 2. Negative 2 times 2 is negative 4, and 0 times 2 is 0. So C prime must be at negative 4, 0. From the origin I just go left 4, 1, 2, 3, 4, there is C prime. I'm going to connect. Okay, and there's my dilated figure, dilated with a scale factor of 2. Notice that the image and the pre-image have the same shape. They're still triangles. They have the same orientation. The triangles look the same, but the triangles have different size. Because what we have done is we have enlarged the figure. We have made the triangle larger by a scale factor of 2. So we would say that these triangles are not congruent since the corresponding sides are not the same length. Instead, we would say these figures are similar. They are similar figures. That's what dilations produce. Dilations produce similar figures. Alright, so this is an enlargement. Our scale factor is 2. 2 is larger than 1, and so it produces an enlargement. The second example, this is from number 16 on page 2 of your packet. We'll see an example of a reduction. And so here we have triangle ABC, and here are the coordinates of the pre-image. We're going to dilate this given a scale factor of 1/4. Alright, so what this means is we multiply each of the coordinates by 1/4 to get the coordinates of the image. Alright, so A, if A is at 0, 4, well 0 times 1/4, that's still 0. 4 times 1/4, that's 1. Alright, so A prime must be at 0, 1. 0, 1. There's A prime. B is at 4, negative 4, so multiply each of these coordinates by 1/4. 4 times 1/4 is 1, and negative 4 times 1/4 is negative 1. So B prime is at 1, negative 1. Right 1, down 1. There's B prime. And finally, C is at negative 4, negative 4, and multiply each of those by 1/4, you would get negative 1, negative 1. That's where C prime is. Left 1, down 1. C prime. I connect those dots to make the triangle, and as you can see, the triangle it got smaller, right? It reduced because our scale factor of 1/4, 1/4 is less than 1, and anytime you have a scale factor of less than 1, that is a reduction. Your image will be smaller than your pre-image. All right, these still have the same shape and the same orientation, but the size of the triangles are different, and so again, they are similar figures.